Hello, I am Evan Romrell,
I'm Jerry Bryan.
and this is our team presentation. So, um, our first thing we'd like to share is the 7 steps that we use to create our function, purchase water in our controller. So the step 1 is to clearly define the problem. And so this comes from our end user story. And so it says, depending on which port and which shop within that port was selected, it will display the player's current holding of gold and list of items at the shop and the price of each of those items. If the player does not have the required gold needed, it will display an error message stating that they do not have enough gold. So it's going to tell them how much gold and give an option to purchase water and how much is to purchase water. So step 2 will be presented by Jerry.
So next we needed to create the test matrix for our purchase water function. Here we have 7 test cases, and they're very well labeled here. Our first test case, we put in possible values that the user may have, as seen here. So the water is actually the amount of water that the player would have in their inventory. And the amount of gold is their amount of gold they have in the inventory. The desired water is how much they wish to purchase from the water store. And then this here is the water price. So what we wanted to return was the desired water, as that will be added to the inventory if the test case, if it evaluates well here. So as you can see here in this first test case, there is no error. So it's correct. So they would have those 4 units added to their inventory. The invalids here, and we'll discuss why a little bit more in detail, these errors down here, are basically just because we don't want them to be able to purchase negative amounts of water. We don't want them to be able to purchase more than a certain amount of water, which is 10 units. So here you can see it is 11. So they're trying to buy too much. Here they're not buying enough. And then in this test case here, they just simply don't have enough gold. They needed to have 25 gold, and they only have 24. And then over in these last 3 rows are the boundaries for the purchase water function.
Alrighty, so step 3 was to outline the solution. So 1 is describe the task of the function as specified in the end user story, and that is to check the gold and return the water purchased. 2, list and describe each of the input parameters as defined in the function signature. And so that's going to be the water price, the gold, the desired water, and water. And where water price is the cost of water in terms of gold. Gold's the amount of gold in the user's inventory. The desired water is the amount of water to be purchased. And the water is the amount of water the user has in their inventory. All right, and then 3 is describe an output value returned for the function, and that is the amount of water purchased. If it's a positive number, then that's how much water they purchased. If it comes back negative, it is an error, and we have set up specific negative numbers for the type of error it is. So 4, list any validation rules defined in the end user story, then define the validation rules for each of the input parameters in the function. These may or may not be explicitly defined in the end user story. If they are defined in the end user story, then you need to get with the client and the end user to determine what the validation rules are. So we have the amount of gold required. Users must have required amount of gold in order to purchase water, cannot have more than 100 units of water in the inventory, and desired water cannot purchase negative amounts of water or more than 10.
Okay, so after we had given the outline of the solution we move on to step 4 where we're testing the algorithm. So we created some pseudocode here, which is not directly implemented into the program just because it's not properly written, obviously. But this is the code that we used simply to test the algorithm and test the test, to use the numbers we implemented in the test matrix. And by using this pseudocode here, we were actually able to receive the desired and expected results.
So step 5 is to translate the algorithm into code. So we took this and we changed it into actual gold. So we put, this is a public double purchase water with the parameters of water, gold, desired water, and water price all as double values. And then it's going to go through this if statement, desired water is less than 0 or desired water is greater than 10, it's going to return -1. And then if gold is less than desired water, less than desired water times water price, then it's going to return -2. And then if double new water, so it's going to create a new variable called new water total, and it's going to add the water that they have in their inventory plus the desired water. And if the new water total is greater than 100, then it's going to return -3. If all these, if it passes all these validation statements, it will then just return the desired water to signify that they can purchase that the water that they wanted, and it will then later in the program handle the actual changing of the inventory.
All right, so after we had gotten that far and implemented the code, the algorithm into code and implemented it into our program, what we did is we needed to create and run the test cases to verify that the code is working as specified, which is step 6. So what we did here is we have our port control test file. So, and this is for our purchase water function. So here we have each test case will begin with will be represented with a print line to the user here in a second. Now what we have are these possible values for each of these items here, the water, gold, desired water, and so forth, as well as our expected results. Now if we test this port control test, we will find that the purchase water, all test cases worked, and we have 100% passed. In fact, all of these cases, but we'll discuss these a little bit later.
Alrighty. So step 7 is to deploy the changes to the repository. So that is just a simple step where I will go over to my screen to demonstrate this. So in here, as we can see, if we look right here, this is supposed to be the word destination. Well, it's not spelled right, so we should change that. Well, since Jerry already has this file and we need to update it, I'm going to show how to do that. So I'm going to right click and I'm going to use the git. And the first thing I'm going to do is I'm going to pull to see if he's made any changes. Okay, now that it's pulled, I'm going to use the git. And I know you don't need to add right now because there isn't a new file, but I just find it good practice to just to do that, so I'll always not skip this skip the step. So after the add, we're going to do we're going to do commit. And we're going to commit this, and I'm going to say, so today is 6-9, and I'm going to say that spelling correction. So then I'm going to commit it. So, and then I'm going to use the git, and I'm going to use remote, and I'm going to push it to the remote repository. So now that I am pushing it, the next time Jerry pulls it, his file will now include that spelling correction.
Okay, so after we have completed all 7 of those steps, we were able to implement that into that function completely into our program on both of our ends. Now what we want to discuss are a couple of selection statements that can be used in Java. And the first two, which I'm going to go ahead and discuss, are if-then statements and if-then-else statements. So an if-then statement will first check the conditions in the if statement. Now, an example we have here is in our core control file. For example, here we have an if statement, which begins here with if and ends with this curly brace here. So what it's going to do is check the conditions within the if statement, which are these here. The desired food in this situation needs to be less than, in fact, we'll go with water because it's what we were using before, which is basically the same. Desired water needs to be less than 0, or desired water needs to be greater than 10. Cannot be, sorry, this is the cannot be. So desired water cannot be less than 0, or desired water cannot be greater than 10. I got a little too down. And so it will actually check the conditions. Now, if the conditions are met, it will execute the block within the if statement. For example, this return here, this error code. So if it is less than 0 or greater than 10, it's going to say, hey, something's going on. It's going to return that -1 error code. Now, if the conditions are not met, it will skip the block within the if statement. Now, the if-then-else statement, which we don't have an example of here in our program, as we've not used one yet, but it's very similar. It will actually check the condition in the if statement, and then if they are met, it will execute the block within the if statement, just the same as the if-then. Now, the difference is if they are not met, it will execute an else statement, which comes after the if statement, and that's what we'll be doing.
Alrighty. So another second statement that we have at our disposal is the do while statement. And here we're gonna just look at the do while, and it's this block right here. So what the do while is a loop block where it's going to say do this block of code while this statement is true. And so what it's saying is, so in this case, when it's saying not done, so when not true is what this is saying. So if it's not true and the statement is not true, then and the statement's false, then that is a true statement. So then it will be true. If this is true, then it's going to loop back and it's going to do this block of code again until this block of code, until this statement in this while is until it's false. And so the while do is very similar to the do while. And if you can just imagine with me, if we were to switch this and these in the proper way, it's going to check, okay, while this condition is met, if this is true, then it's going to execute this block of code. And then when the code is done, it's going to go back up. While if it's still true, it will loop again, and it'll keep looping until the while statement is no longer met. So the difference between the do while and the while do, and when you'd want to use it, is the do while will always execute the block of code at least once. It will execute. It checks the condition after the block of code has been executed. So in this case, it doesn't matter if this gets changed to yes or true, or even if I were to change this to true, which is to set done equal to false, which makes this statement true. If I were to change it to false, to true, it'd make this while false, and so it wouldn't fit the condition. Even if I were to do that, it would still do this block of code first, and then it would exit out, assuming that it remains that way. However, in a while do, it will only execute the block of code if the condition is met, and it checks it first. So if you want it to loop, but you want it to check before, you only want it to loop when a certain condition is met, then you use the while do. Or if you just want it to loop, I do it once and then loop if it's if nothing has changed, then you use the do while.
All right, and now the last selection statement is the switch statement. Now, the switch statement basically gives a variety of cases, and then each case has a different outcome for for each individual case. And then if a break is used in between each case, it will actually leave the switch statement. So here in the help menu view, what we have going on here is we have various cases. For example, if the user were to select G in the help menu, it's going to call on the goal of the game function, which will display which will then return and display the goal of the game to the player. The same as how to move and the resources available and so on. Now, what the break will do is once they select G and this here is executed, it will break and leave the switch statement. If the break is omitted from this entire switch statement, it will go through every case, but we wanted it to end after the selection was made.
Alrighty. So the next thing we're going to show you is how is our control units test. So I'm going to share my screen again. So for mine, I did purchase food, which for my individual assignments. So purchase food works pretty much identical to the purchase water. So again, it's taking the amount of food that the user has, the gold, desired food, and food price, checks to see they're not, but they're buying the right amount, trying to buy the right amount of food. It's going to check to see if they have enough gold to purchase it. It's going to set a new food total. If the new food total is greater than 100, then it's going to return 3 as an error. And then if all the validation is met, then it's going to return desired food. And so we're going to test it in the port control test. I'm going to wait for my NetBeans to finish the test. All right, there we go. There we go. And as we can see for purchase food, we have all of them passed. And our test matrix that I used for this is identical to the test matrix used for the purchase water.
Okay, and now the function that I did was the purchase armory, which coincidentally is actually basically the same as the desired food and the desired water, which we explained why we did it that way earlier. We just wanted to have the same layout with the errors. So basically what I have going on here is as similar in the other two, we are calling in the weapons, the gold desired weapons, and the weapon price. And here it will check to see that the amount of weapons that are the desired weapons is within range of what we want the user to be able to purchase. We need to make sure they have enough gold, which is what we're doing here. And then we want to add the purchased weapons to the desired weapons to the current weapons, which will give them the new weapons total in their inventory, which cannot be greater than 100. So again, if all of these conditions are met, then it will return the desired weapons to the inventory. So if we test that here in our port control test file, which is down here, a similar layout to the other tests we had earlier with the purchase food and purchase water, with each test case individual. We test this here. We'll see that along with the other two tests, the purchase armory tests were successful 100%.
Alrighty. So the next thing I'm going to share with you is the scope of a variable. So as I switch back to my screen, the scope of a variable is essentially just when the variable can be used. The scope of the variable is in the function it was defined in, or the function it was created or declared. And so in this case, this variable done is declared right here. So this function is its scope. It can be used in any place in this function, especially since it was not in any other block of code, just in the general block code. It can be used in any part of this function. However, if you leave this function, then it is no longer in scope. So like in here, it's stepping down into the get menu option function. So at this point, even though it's still in the middle of this block of code, when it's stepping into this function, done is no longer in scope. And so this function cannot use done. And so essentially the scope is this when a variable can be used.
All right, and so explaining done as well in relation to the lifespan of a variable. Basically, it's very simple. So the lifespan will begin when it's declared. So here, this lifespan begins right here. Now, the lifespan ends when the block of code in which the variable was declared ends. So as we can see, this block begins right here, and it ends down here with this French bracket. So the lifespan of done begins here and ends right there.
Alrighty. So because of this, of the scope and lifespan, sometimes functions are, we don't want the values to, we want to be able to use the values in other functions. Say in here, we want to be able to get the, so, oh, I guess I should probably switch my screen. There we go. I was wondering why you couldn't see my screen. Anyways, so in here, this is their selection, their menu option. We want to be able to do something with this. Well, as soon as this function ends, and as soon as, or if we leave the function, then this function, this variable it's called the primitive variable, is no longer in scope, or the lifespan ends, depending on which comes first. And so we want to be able to use it other places. So in here, we're going to call this function. We can actually pass the value of this function, of this variable into this function. So when we put it into this parameter, and here, it will actually pass it the value of it. So whatever value it is, it's going to pass it into here, and this function is going to catch it, and then it's going to play with it. So it's actually passing the value of the variable. The variable goes away, the original variable, and it's catching it into a new variable.
All right, now slightly different to that is when we want to be able to use an object in another location as well, similar to a value. Now, objects are things that are passed by reference. So where primitive values are passed by value, objects are passed by reference. So here in our move location view, we can see that we want to use the C object right here in this line. So what it's going to do is it wants to pass, what we're going to end up doing is passing the C object from our location control. Here we're going to return the C object to the move location view, so that way it's able to use the object in multiple locations within the program.
And so that is our presentation. We hope you enjoyed it and hope it was insightful. We will talk to you. We'll see you guys later.
All right, thank you. You guys have a good.
Bye.